Is my screen visible to all?
Yes, yes, we are able to view the screen.
Yeah, okay. So, good morning, everyone. My name is Adil Ansari, and I would like to thank AWS Club FGIT for inviting me as a guest speaker for a DevOps session. But before proceeding with the session, let me give you a quick intro about myself. So, I'm a DevOps engineer at IGT Solutions, and I have more than 1.5 years of experience. I am also a AWS community builder. And to know more about me and to connect with me, you can follow me on LinkedIn. This is my LinkedIn profile. You can search there. Okay, so now let's come to today's session. So today we'll be learning about containerization, and if I say we'll learn more specifically about Docker. Okay, now let's try to understand what is containerization, what problem it is solving for us, and why should we care about it. I mean, why should we learn containerization? So first, let's understand the problem. Why containerization was invented? What was the problem? Is it solving? So let's take an example. Assume you are a developer and you are developing an application that requires some XYZ libraries or XYZ version of Python or Node.js or any other language or software. Now you if you are developing the application in your local environment, you will install all these things on your local machine, and you develop the application and it's working perfectly. And now the operations part come into the picture. You have to deploy this application so everybody on the internet can use it. But the main problem that arises here is setting up the environment that can run your application. Suppose what if where you are deploying the application on a system where architecture is different than your local system architecture, or what if the Python or Node version is different, or multiple versions of Python or Node.js or any other tools are conflicting with each other, etc., etc. There are many problems that arises. Although it is true that all these problems can be solved without containerization also, but with containerization, you can solve all above problems easily with very less effort and without worrying about underlying operating system. So, what is containerization? Containerization is a technology, or you can say containerization is a way to bundle your applications into a package with all its dependencies and environment conditions so that it can be deployed and run anywhere without worrying about the underlying operating system or hardware. And the package which containerization creates is called an image, container image. And when we run or deploy that image, then that running image is called a container. So that is a container. Okay, we understood what is container and what problem is it solving. So what is Docker? Now let's see. So Docker is a container engine that is used to start, stop, and manage containers, and it is one of the most popular containerization tool out there in market. So this is an image. The this is infrastructure. The your physical operating, I mean physical laptop or physical desktop. On top of this, you install Windows 10, Windows 11, or Ubuntu, Red Hat, Linux, whatever you install. And on top of your operating system, you install Docker engine that is provided by Docker. So it creates a layer. On top of that Docker layer, you can run multiple containers, and that each container is isolated within its environment. Uh, till now, does anybody have any questions or doubts before we proceed to practical? I mean, we'll focus more on practical without wasting much time. So I hope everybody grasps this. Okay, let's continue. Okay, so to install, first, before proceeding to the practical, you need to install Docker. So for installing Docker, you can follow this is official guide from Docker itself. So I'll paste this link in the chat, and you can install Docker in your operating system. And this step is only for Linux users. So once you install Docker engine in your operating system, then you have to enable Docker, because Docker run as a daemon service. So you need to enable it so that every time when you restart your system, um, it starts automatically. And the second command is to start the Docker container engine. Okay. So for today's practical, I'll be using AWS EC2 machine I created last night. So on that EC2 machine, I'll do practicals and explain each and every command to you. I already have Docker installed, and Docker is running. How to check Docker is running? You can use systemctl status Docker. So Docker service is running, and so now we can use Docker command. Okay. The very first command that you need is to check what images are there. Uh, what are images? Images I already explained that the application bundle that is packaged is called an image. So to check what images are there in our local system, we can use Docker images command. So there is currently only one image, that is hello world, and the tag is latest. Okay. You may ask that why it is saying 7 months ago, although I created this last night. So this time shows you when image was built. So originally image was built 7 months ago, but I downloaded it last year. So this time shows you when was the image built. Okay. And to check what all containers are running, we can use Docker ps. So Docker ps command shows you the running containers. And what if you execute, you run a container and it stops. Now you want to check that container also. So there is a flag -a, Docker ps -a. This command will show you all the containers, including stopped. So status is exited, it means it's not running. Is my font size okay to you guys? Anybody can confirm, or should I
Yes,
make it
that's okay.
larger?
That's okay.
Okay. Okay, great. Okay, let's proceed further. So this is my local image, but from where this image is coming? So this image whenever, so let's first pull an image, then I'll explain you what is it doing. So Docker pull is a command to pull the images from the internet. Docker pull, then we'll give a name, HTTPD. HTTPD is an image of HTTPD web server. So if I run Docker C, it downloads the image from the internet. From where it is downloading, I'll show you. Now you can list the images. Sorry, Docker images. Okay, that is a typo. Docker images. you can see the HTTPD image is downloaded and it was created 7 weeks ago. But from where it is downloading? So by default, when you install Docker, it downloads all the images from a registry. So registry is like you place your code on GitHub, and we in Docker images we place registries. We place images uh, on the internet, and that is called a registry. So Docker provides its own free-to-use registry, that is Docker Hub. You can search Docker Hub on Google, and here you will see hub.docker.com. You can create an account there. You need to have a Docker account if you want to push your images into that registry. But to download public images from the registry, you don't actually need an account. So we'll see HTTPD. Here you can see HTTPD is the image, and it has 1 billion plus downloads. So this was the image we actually pull. You can also check this command docker pull HTTPD. This will pull this image. But by default, if you see here, it is saying tag latest. What is tag? So when we build our Docker image, we give it a tag, a name colon tag. So name is the our image name, and tag in tag we can say like versioning. We can use tag for versioning. So by default, when we don't give any name, it takes the latest as a tag. But what if we want to download older Docker image of HTTPD? So here you can see there are multiple tags out there for this particular image. Each image has its own tag. It can be same, it can be different. So it has multiple tags. Bookworm tag, Alpine 3.19, 2.4, 58, and there are many. Suppose if you want to download 2.4, so we'll give docker pull httpd colon 2.4. This will uh, download the httpd image with which has tag 2.4 mentioned. So if I again list the images, it will show you now there is another httpd image with the tag 2.4. Hope it is clear for all. Okay, now let's try to run this container httpd. So to run a container, we have a command run docker run. Then after that we give the name of the image, which is httpd. We can also define tag here 2.4 or latest. If we don't define any tag, it by default takes the latest as a tag. So if I enter this command, it will run a container. So it is running a container, and let me duplicate my 40 session. So if I check docker pl, then you can see httpd from the image httpd, a container is running, and this is a container id. Container id is unique for every container, and it was created at this container was created 18 seconds ago, and this is the port number which this particular image is exposing a port, and that port is port number 80. So you can access the services of this particular container at port number 80. But how do we access this? what is the IP address of this image, of this particular container running. So one of the option is, you can see here, IP address is already given, so we can use curl. Okay, so this is a private IP address, not a public IP address. Uh, you cannot access it over the internet. Only this IP address is accessible within this machine only. So if I use curl, then that IP address, it should give me some sort of, it works. Whatever this image is exposing, it shows here. So it is saying it works. But if same IP address, I open it in my browser. So this machine is different. This Ubuntu machine is running on AWS, so it is different. My local machine, my system, Windows system is totally different. So if I want to access it, it won't be accessible. So it's not accessible, right? But what if you want that it should be accessible? So for this, you have to expose, I mean, you have to map a port of the container to the host machine. Host machine in our case is this. Is this Ubuntu machine is host machine in our case. So we need to map a container port with our host machine so that we can use the web service with the public IP address of our host machine. So for this, there is a tag. First, let me stop this container. Okay, before port mapping, uh, one more thing about running a container. So currently, this container is running in the foreground. If I want to enter any command, it will not allow me. cd, ls, it won't allow me because it is not a command prompt. It is a running process which is showing here. So to stop this, I'll press Control C. It terminated this. If I check with Docker ps command, so the container is exited or terminated. Okay, so to run the container in the background, so that after even the container is running, we can execute our command. So for this, there is a flag with -d. -d means run the container in detached mode. Uh, It means run the container in the background. So docker -d, then the docker, it is docker run -d, then the image name httpd. So you will see now we got our prompt back and we can use command, and it gave us the container ID. So this is the container ID. If I check docker ps, it is same c7cfb0. It only in the docker ps command, it only shows some initial part of the container ID. If you want to check whole container ID and more things about this container, so you can inspect this particular container using docker inspect, then container ID. You may ask that it is not a complete container ID, so why I am uh, writing this, not this one? So there is one thing, container ID is unique for all, and you can also paste some initials of the container ID, but it should be unique. Suppose there are multiple containers running. Let me run multiple containers. So here multiple containers are running. If I type docker inspect, I have to give at least 3 to 4 initials which should define the which should be unique for the container. Here it I can write even 5941. For this one I can write 4SC7 and so on. So let me show you. Docker inspect, then initials of container ID, but it should be unique. Suppose if a container is 475F and something, and another container is 4SC75F and some other stuff. So we cannot use this 4SC75F. We have to use extra initial like 988. So that is required. Okay, now Docker inspect command, it shows you everything. What are the processes it is running, what command is it using to run the process, which image is it is taking, and what is the IP address of this particular container. So it is giving us container ID, a timestamp when it was created, its status, running, and this is the image ID from which image it is created, and so many things. And somewhere between here you will see its IP address. Let me just check. You can see here ports also. Yeah. So here is its IP address. So this is IP address of this particular container. And you can explore this command. Okay. Now we were talking about port mapping. How to access this web service, whatever our image Docker container is exposing, to use publicly. So these many containers are running. So first let's stop all these containers. To stop the container, we have a command docker stop and then container ID or container name. So by default, when running a container, let me run again. Docker run -d for detached mode. Then our image name httpd. If I don't give a name here, it by default generates a random name and assign it to the container. So here you can see names. This is Sweet Juliet, Vibrant Bell, Epic Blackburn, etc. So if you want to give your own name, so for that you have to specify hyphen name and then your container name, my web server. So this name I have given, and at the last you give the image name. So if I run this now, it gives the container ID, and you can check with docker ps command. This is the last container status up with from 8 seconds, and the name of the container is my web server. So you can give a name to your containers with hyphen name option. Okay. So to stop all these containers, we have command docker stop. Then you can either use container ID to stop the container. Let's check docker ps 5941 AC. That is no more running. And you can also use container name to stop the container. Docker stop my web server. Now let's again check docker ps. So you can see my web server is not running. But if there are multiple containers, let's stop all these one by one. Okay, let me show you how you can stop all these containers with a single command. So for this, first let's see one thing. Docker ps hyphen q. What hyphen q means? Hyphen q will only query the container IDs. So it will give you the container IDs of the running container. And if you want to stop them all, you can use docker stop. The command is again same, docker stop. Then you have to use shell extension. I mean, it is related to Linux, not something that is related to Docker, but you can just manipulate things. Docker stop. Then this dollar symbol and this braces means whatever you will put inside this, inside these braces, it is a Linux command. So here I will use docker ps hyphen q. So this command will give me all the container IDs that are running, and it will pass these container IDs to the docker stop command. So docker stop command will stop all the running containers. Now let's check. You can see all the containers have stopped. Let's see all the containers that are stopped. So these are all the containers that are stopped. But if you want to, if if you want to remove these entries also, you don't want to see these in exited status, you want to just remove them. So there is a command docker rm. Docker rm means docker remove. Then it also either you pass the container ID or the container name, and then so I pasted the ID of this my web server, and let's check. Docker ps hyphen a my web server is removed. Okay, now this is a question for all the students. Give me the command to remove all these stopped containers in a single line. You can type your answer in the chat. Let's see who got it. Is this clear to you guys? If there is any doubt, I'll explain again.
I think so. RM stop இல்ல RM இரு RM
Okay,
அவசரப்படாத
let
wait.
me explain this again. So, to query the container IDs of these stopped containers, first let's see how do we list stopped containers. That is docker ps hyphen a, and in this command we'll just add a queue. So it will only give us container ID. Now this is giving us only container IDs of stopped containers, and again you can use docker stop command. Then this is a command within a command, that is docker ps hyphen aq, or you can use qa. Both meanings are same. Sorry, not docker stop, because these are also stopped, so this command does not have any effect. We can use docker rm command, docker rm, to remove these containers from the exit status also. Now if we check docker ps hyphen a, all the stopped containers are also deleted. Yeah, so Abhimina Kanan has tested the right answer. Great. Okay, We'll see how to remove stop Docker containers. Now let's see how to remove Docker images. Suppose if you have downloaded many Docker images and it is taking a lot of space, because each Docker image stores in our local system and it consumes some space. Let's this HTTPD image is taking 174 MB. This one again taking 174 MB. This Hello World application is taking just 13 KB. So, but if I downloaded it accidentally and I just want to remove this particular image. So, to remove a Docker image, we have a command docker rmi. I means image. So, docker remove image. Then you can paste either image ID or image name httpd. But if you only type image name, by default it takes latest as a tag, so it will remove this one. So we have to give it that I want to delete the image with the tag 2.4. So it is saying untagged. And now let's see docker images that httpd with tag 2.4 is now removed. You can again, it is just removed from your local system. You can again download it from the Docker Hub registry. Okay, now I skipped the port mapping. Sorry. Now let's again jump to the port mapping. Docker PS. Now container is running. Just let's quickly run a web service. Docker run -d httpd. Now you can see how simple is it to like run a web server. You just have to do some command, execute some command with a one or two command, docker pull httpd and docker run httpd, and your web server is like running. So this is the ease the Docker and containerization provides you. So this is Docker PS, and you can, okay, so to map your host port with the port of container, there is a flag -p. So -p means port, and if you want to map port number, suppose you want to port number 8080 of your Ubuntu machine to port number 80 of your container. First, we have to give port number which we want to map of our host machine to the container. So it will map container port 80 to host port 8080, and then name of the container my exposed server, and then we will give the image name httpd. Oh, sorry, I have to run it in the background so that I can also access my terminal. Okay, so it is giving an error. It is saying Docker error response from domain conflict. The container name my exposed server is already in use. But if you see Docker PS, this container is not there. So why it is giving the error? Because this does not check with the running container. It check with all existed containers. So if I check Docker PS -a, so here you can see my container is there. It is stopped. So if I want to run a container with the same name, first I have to remove this container. Else I can use another name. But I want to use the same name, so I'll remove this stopped container, docker rm, and then the container ID or container name. Now check docker ps -a. Okay, great. Now let's again execute this command. Now docker ps. So here you can see it is saying 0.0. It is showing our local machine port number 80 mapped to the port number local machine port number 8080 mapped to the port number 80 of the container. So if I want to access this from my local machine, I can also use localhost 8080. It is working. I can also use container IP address. Let's quickly get the container IP address. Docker inspect my exposed server. Then grep 172 dot. So this is the container IP. Curl 172. But if I want to access this service with the container IP, it is not running on port number 8080 because the service is running inside container 8 port number 80. So I have to use that port only. If we don't give any port for a HTTP request, it by default take port number 80. That means this command and this command are same. Okay, cool. And I want you guys that you can you just use this in your system either using curl or in your browser. Let me quickly ping you my public IP address of this Ubuntu machine. So if I copy this public IP address, and earlier it was not working because it was private IP address of the container, but now it will running on port number 8080. Again, it is not working. Why? Because there is a thing called firewall that AWS provides by default. So I have to first allow this port number 8080 in its firewall, that is security group, so that the machine can listen on port number 8080. Just let me quickly allow it. Okay, now if I refresh this one, it says why it's not working. Okay, HTTPS. It won't work in HTTPS. It will be in HTTP. So here you can see it is giving it works. So let me just quickly paste this in the chat. You can also check. Okay, cool. Now, okay, and suppose you want to execute a command within a container. In your local machine, you can just type your command and just execute it. But how do if you want to run a command inside a container? By default, it is not giving you a shell to run the command inside the container. So how do we do this? So for this, first let's check one of our containers. So this container, let's copy this container ID. And to execute a command within a container, we have Docker exec command. So Docker exec hyphen it. Hyphen it means interactively, and the your container ID or container name, anything you want to put, and then the command you want to execute. Suppose I want to execute ps command, Unable to start the process, executable file not found. Okay, so it is saying ps command is not presented in the container. We use some other command like ls. So it is showing us these are the files or folders within the container. ls hyphen l. So you will say, is it from my is it something data from my system? No, I don't have this data. See, these are the data within the container. And in httpd, so httpd web server, when we run it, by default takes the html file to host from a directory that is /var www html, because httpd server is not running in my ubuntu machine, so it is saying that no such file or directory. It means this directory is not present there. But if I again run this command in the container, okay, it might be it not be CentOS based. Let's just check it. So in Linux machine there is a file etc os release, is a file that shows you the operating underlying operating system and some other details. Okay, it is Debian based. It can be Ubuntu or something. It is Debian based. So this is something that is related to CentOS systems or Red Hat Enterprise Linux. So because it is Debian, it may be exposing the HTML file from somewhere else. Let me quickly check if CentOS based HTTPD image is there. Okay, fine. Unable to check it now, but let's create our own image. So the next part is also building our own image from a Docker file. So let's quickly create our Docker file. First, let me stop these. Okay, let me stop. Okay, let it be running. Now we'll create a Docker file. What is Docker file? So Docker file is a file that gives the command to the Docker engine that these are the steps I am providing you. Build this build the Docker image based on these steps. So let's quickly write a Docker file. So very first part is from. The from is means you have to take a base image. It can be Ubuntu, it can be HTTPD, it can be CentOS. So for our scenario, we are taking CentOS. Okay, cool. I'm not passing any tag here, so by default it will take latest tag. Now I want what I want to run because it is CentOS. The package manager in CentOS is yum. So I will use yum install httpd -y. -y option is that when we install any particular tool, it asks for a confirmation. -y means don't ask for confirmation, just install it. What is the run? This part which I am highlighting now, it is a Linux command, CentOS command. But this part in yellow color, this one, it is a command of Docker image. So it is saying run means run this particular command at the build time, not the runtime, at build time. So while building the image, run this particular command. Okay, and paste this run echo IAM web server. I don't think output redirection works here. So copy. The copy command is used to copy the files from your host machine to the container. So I'm copying a file name file.html. Where in the var www HTML folder. So it will copy there. But this file is not present. I know I will create this file. I mean this file should be there in your local machine. And then this text I have to also I have to run the HTTPD server. So for this we'll run using CMD. What is CMD? CMD is a command in your Docker image to tell that when you run the container, what command will be run. So I will use http. You have to give in quote httpd. Yeah. Cool. Now let's try to build the image. To build a particular image, we have to use docker build command. I'll also explain it. Various options. Docker build. Then -t. T means tag. Which name and tag we want to attach it. So I want to attach it with my image colon. If I don't give any name, it takes latest as a tag. I want it as v1. Then dot means first. Let me create a. And now I'm inside this particular Docker folder and only Docker file is there. Now let me build this Docker build -t for tag, then my image colon v1, then dot means the Docker file is present in current directory. In which directory I am, the Docker file is presented here only. Docker build -t and it will give an error. It is saying error file.html, but it is not there. It is saying not found. So first we have to create file.html. Let me just create file.html. I am a web server and I am running on CentOS container dot dot dot. So let's check. File.html is there. The content is there. Now let's again run this command docker build. It won't give any error. Okay, first it is what is saying install http try to download metadata. Okay, so What is this app stream? What is this metadata for repo? It is again something related to CentOS system. The image which we have taken from the internet is not pre-configured. It's repository. What is a repository again? Okay. So in Ubuntu, if I install sudo apt install Apache 2, yeah, Apache 2. So here this package also Apache 2 is Ubuntu package, and it is again coming from a repository of Ubuntu. So it is pre-configured in my machine. But the CentOS image which I have downloaded from this Docker Hub is not configured with its repository. So what can we do in this case? Let me try with some another. I'll find. Let's check this one if it works. Docker run. If you directly run Docker run command, then it will first Docker run happen. It will first pull the image from the internet and then it will run. So it is saying unable to find it locally. It is pulling from the internet. It is exposing port number 18. If it works, let me check if it is using that directory docker apt-it, then container ready. What is container? This one. Then ls-n or no again. Okay, I think we have to use some other image. Just give me a second. I'll maybe we can use Python for our demo. Okay, let's try to, instead of HTTPD, let's try to run a Flask application. Okay, from Python 3.11, then we have to install script install Flask. Copy dot dot. What is dot dot? Dot dot means whatever in this current directory, copy all the content into the container. And then at last cmd f.5. Okay. Now let's ask ChatGPT to write a simple Flask file, or we can search online. If you don't understand Flask or Python, don't worry. It is not something related to sorry, not something related to Docker. What am I doing in this? It is importing Flask from this, and one more thing. I'm not sure whether it is right or not. Let's quickly check it. Sorry for the delay, guys. I should have taken the right image earlier, but let's try if it is working or not. Else, I will,
Send the charge proposal.
after this session, I will create a Docker file and a simple Flask or HTTPD file and will share with you guys. Docker. Let's check our image is created or not. We have created the image with my Flask app :v1. So my Flask app with the tag v1 is created, and you can see the image is very big. It is 1 GB. Docker run, and then my Flask. It is saying a response from daemon failed to create Flask for container failed to create shell task for CI runtime. Python must be Python 3. Time also it won't work. I will explain you one very important task in when we deploy things in production, and then we'll end this session. Oh, it is a typo. Sorry for that. Why? So every time when you change anything in the Docker file or any of your code, you have to build the image again so that it can take the latest file and folders from your directory. So this is why I'm building this again. Okay, now it's running great. And it is also exposing me. Currently, it is running. It is only accessible within the container. It is saying 127.0. It is a loopback IP. Loopback IP means the local host which we type for this IP address. But if you curl this one, it won't work. Let me just check, because this time I'm requesting this. It is taking the host machine loopback. I mean, it is supposing it is host machine, and here it is supposing it is container. So I have to give the container IP address. Let me check one thing also in the main file. That's the file. In these kind of scenarios, ChatGPT is saver for everyone. Okay, I got correct. Instead of installing Flask here, what I'm doing, it is related to Python. I'm installing the dependencies from requirements.txt. And just let me check. There shouldn't be a typo. Okay, cool. Let's give this the tag v2. And after this, I'll explain you one very important thing. What is it saying? Oh, requirements for TXT file. Okay, so here I'm installing first and copying later. So what I have to do, I have to, okay. Also one more thing, I'm doing some shitty thing in the Python. Don't worry guys, that is not something related to Docker. Just be with me. I'll explain you everything. And at the last, one very important thing in the production environment. Okay, we have Docker images. Now we have a new image, Flask v2. Now we'll run Docker run, and then my Flask is colon v2. So now it is giving me two IP address. Earlier it was only giving me this. Now it is giving me this also, because this is again something related to Python thing. So don't worry about this. Now let me ping this IP address. It will work. Curl. So message hello world. So it means that our Python application is working. And now let me expose it so everyone in the session can access this one. Docker create. Let me quickly Docker stop from the image. It is the image. Okay, we have already stopped it because we were running it in the foreground. So Docker run and then -p, or let's this time make port number 5000 to port number 5000. Then my Flask application colon v2. Great. This time, if I want to access it from my public IP address, because I have exposed it, this is my public IP address at port number 5000. Okay, this is again, I have to add a rule for port number 5000 for the because of firewall. So here you can see now this is working. Yes, let me test it you. So our Flask application is working, and you guys can also hit this. Okay, now let me
எனக்கு மட்டும்
tell
வரவே
you a
மாட்டேங்குது.
very important thing in production environment, and we'll finish this session. And if the time allows, I'll also explain volume mountings also.
அவர் அனுப்பிச்சது ஃபர்ஸ்ட் நீங்க எனக்கு வேலை செய்யணும்.
Port mapping. Okay, so let's first, before understanding what I'm going to explain, first let's see what actually are images formed of. So if I add this Docker images, Docker image, then inspect, then let me use image ID. So here you can see layers. What are layers? So this particular image is formed of these layers. This is layer 1, layer 2, layer 3, and multiple layers are there. So any image, Docker image, is a not a complete image within itself. It needs some layer. It means this particular Docker image which I created, my Flask app v2, it it is a byproduct of these these 10 to 12 layers. Each layer is a sort of image. So if I delete any of these layer anyhow, so what it means, because my particular image is depending on this particular layer, so my image won't work. My image will get corrupted. But what is use of these images? Let me show you. It is used to reduce the storage which it is consuming in the host machine. Let me explain diagrammatically. Okay, suppose I have created my own image. This is layer 1, this is layer 2, this is layer 3, and this is layer 4, this is layer 5, and so on. And each image has some ID. Let's call it A, B, C, D. Okay, let's A, B, C, D, E, F. This is here. This is GH. this is IJ, this is KL, MN, and all these layers combinedly make my image. So it is not the case that these layers are bounded within my image. These layers are independent. So it is not the case. I created this box here just to show that with these images, my this particular with these layers, my image is formed. But it is not. Uh, I mean, it is just a link. This is linked to this. This is linked to. This is linked to this. It is linked to this. It is linked to this. These are just links. And now I want to have the magic comes. If I want to create another image, suppose it again taking ABCD as the first image and ABCD as the first image and EF as the second image and GH as the third image. But fourth layer is different, fifth layer is different. So now this is the magic of Docker. What it does not again download A, B, C, D, E, F, and GH layers from the internet because it is already present in our machine. So it will use these layers. So the storage of these three layers are saved. And suppose there are hundreds and thousands of Docker containers are running and thousands of images are there. And if it would be the case that every image is independent itself and it is not linked with the layer, so every image will consume more space because it will again, if a new image again require this one also gets downloaded, this one also will be downloaded, this one also, but these are also present in our local system, so it gets reused by the Docker. So it will just link this one here, this one here, this one here, and only these two, XYZ and OPG, only these two layers will be downloaded from the internet, and then it will again to like the layers are not connected to each other. And with this, there is one more thing that comes into the picture: caching part. So just let me show you. Let me stop all these containers. Docker hyphen f means if I directly want to stop the containers and also remove, then I have to use the hyphen rf option. Okay, cool. Docker images. Let me also remove these. Docker RMI my class v1 and v2. Okay, now just see the thing. Docker Docker build hyphen t my new step colon v1 then dot. Here you see this part is cached. It means it is not required to again build this part. This is again cached. This is again cached. So how it helps in production environment? Let me show you. I am making a small change in the requirements.txt file. And what change I am making? I am installing NumPy. NumPy is a Python library. Now, what would happen if although this part was earlier, built and it is cached, but now see, v2. Now it is saying it is not cached. It is built again. This pip install hyphen hyphen upgrade pip is built again. Earlier it was cached. And also this part pip install hyphen r requirements.txt. This part is again built again, but it was earlier cached. So why it happens? Why this time it was cached and why this time it has to build again and it took some time. So this is again the game of layer. And here the production part comes optimizing Docker file. So if I show you this Docker file, so each line of Docker file is a layer, is considered a separate layer. So if I am saying this from Python colon 3.11 is a layer, say this is ABCD layer. Oh, let me. This is this one layer. Okay. Copy dot dot. This again a layer on top of this. This one pip install hyphen upgrade. This is a layer on top of this. See, the above layer is dependent on its under layer. I mean, this first layer is dependent on the second layer is dependent on first one. Third layer is dependent on second one, and this one again is a new layer. And then this is not a layer because it is a execution part. What command we are executing? It is not a layers are created while the build time. This runs at a build time, 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 and this runs at runtime. Runtime means when we run a container, and build time means when we build an image. So all these parts are build time part, and this is a runtime part. So what would happen? See here the magic comes. If I make any change in this copy dot dot in this layer, so this is the second layer. If I make any change, if I make any change in this layer, what would happen? All the layers above this layer and this layer will also build again because it was dependent on the layer on second layer, and now second layer is updated. So the third layer will again build because second layer is updated, and the fourth layer will again build because the third layer is updated. So to but you see I have not made any change in the code in this command. So the change is, I'll show you, because I am copying all the contents from the file to the I'm copying all the content, I mean files and folders from my current directory into the container. So because I made a change in this requirements.txt file or in app.py. I just made some comments. This is a comment. Because I made a change in the file and this file is changed, and my second layer is saying copy the files from my system into the container. So again this layer is changed. So what would happen, all the layers in the Docker file below this layer will get executed again. So if I show you, if I build this one, see, the copy layer is changed, so the upgrade layer is also changed, pip install upgrade, and the pip install requirement.txt again changed. And this is just a very simple application. In production, the build steps like pip install -r requirement.txt file is so big means there are multiple dependencies. In our requirement.txt there is only 2-3 dependencies, but in production there are multiple dependencies, 150 plus. I mean multiple dependencies. It is not related to Python. In Node.js or any other kind of language or framework, we have to first build that. Even React also. So this this part gets very costly. This pip install part and pip upgrade part. Pip upgrade is also not very costly, but this part to install all the dependencies, because it downloads from the internet,
Hello,
so
கேக்குதா?
the bandwidth is also used and the time is also consumed. It takes around 4 to 5 minutes, or sometimes it gets up to 10 minutes also, based on how many dependencies are there. So to optimize the time
No,
of
15
building
minutes.
our application, what we don't just copy all the contents directly. What we do, we first copy requirements.txt. We first copy requirement.txt file in the app, and after that we use these options to install those dependencies. And once these dependencies are installed, then we copy the content. After that we copy the content. Now what would happen? See the magic. This time again it is going to build again, because I have made some changes. Hmm. See, the dependency part does not upgrade frequently. It is very rare that we change something in the dependencies in the requirement.txt file or package.json in case of React or Node. See the magic. Earlier I just added a
Engineering
comment in
போட்டுக்கு
app.py
போகாத.
and it built again. Now I'm
Hello.
adding, this is
Engineering யாரெல்லாம்
another
போறீங்க?
comment. Now the magic comes. See, all these built
Engineering
instantly.
யாரெல்லாம் போறீங்க?
This layer is cached because I have not made any change in the requirement.txt file. So it means the upgrade part was dependent on that
சரி,
one and
okay.
it was not changed.
Placement hall கீழ வரீங்களா?
And
வரேன்.
the fourth layer also, pip install -r, it was
எங்க
again
placement
cached.
கீழ?
It's not built again because all the layers above this layer was not upgraded. The copy, Only the copy command is built. See, the copy 5 out of 5. I mean fifth layer out of fifth is copy dot dot, and we generally copy the content of our application. Try to, I mean, in the last, so that the, I mean, so that if we change any code, because changing in the code is very common. We do one change, we get error. We do another change, we get another error. We do change, we fix it. So if it every time it install the dependency, I made just a print statement to debug, and then it is again taking 10 minutes. I'm waiting for it every time I made some changes. So by just by just a simple trick, we saved thousands of hours. We saved thousands of hours of the company, of the workload of the developer, and this is how the production applications are, Docker images are built. So the trick is put those layers on top. Those are rarely changed. Those are and put those layers in the bottom that are frequently changed. This is why I pasted this copy dot dot, because I code changes very frequently. Every time I build, it must be the code is changed. That is why I'm building. Otherwise, why would I build? So, but requirement.txt, that is our dependency part. It changes very rarely. I mean, until a new functionality or new feature is introduced, the dependencies does not change at all. So we put installing the dependencies on top, or any other layer which is rarely changed on top, so that those layers are mostly cached. See this. If I change this time, made some change in the requirement.txt, this time it will build again, and all the layers below this layer will build again. Copy requirement.txt, it was built again. Then pip install upgrade, it was built again. Pip install requirement.txt, it built again. Copy dot dot, it built again. So because I changed something in the requirement.txt, until this file is touched, it will cache. I mean, if you don't change anything in a requirement.txt, it will cache every time, and you will save thousands of hours of workload. And this is how a Docker image is optimized. So I think that's all for now.
சரி ஓகே
If anybody have any doubt, you can ask. You can,
அது
if it is
ஒரு
allowed, you
2
can
minutes நான்
unmute
வந்துடுறேன்
yourself, or
முடிஞ்சிச்சு
you can ask your doubt in the chat.
கேட்டிருக்காரு ஒரு டவுட் கேளு முடிச்சிடலாம்
Hello, sir. So
Yeah,
regarding the
Vikas.
commands we run the Docker file, so can we run more than one command?
No. So
Is
in
there
one
any way to do
container,
that, sir?
no. There is no way, and that is also not feasible. So Docker container is like a process. Let me show you. Sleep 100, not 100, less than sleep 10 is a Linux command that is used to sleep your terminal for given seconds. So it is a command. Okay. In this command only have one functionality. This is to run a process that holds the terminal. The Docker container which we run, Docker PS. I am not saying this. Run Docker. So here you see these none, it has some ID, these none, it has some ID. These are intermediate layers that are formed while I was building my own image. So these are those layers. Docker.
What of thanks? நானா Thank you, sir.
So this thing which we see the container is running, it is like a simple, not a simple, a Linux process.
Sir, rather than commands, if I use the command with the run now, it will give a layer now.
I didn't get
So
your
I don't
point.
want the layers. How can I edit the layer and run a command? Run it as a command.
You don't want layers to be created. Is this the case?
Sir?
Actually, you are your voice is a little low. So
Sir, I don't want a command to be as a layer. So when I run a command with a run command, it will form a layer, no, in the
right,
Docker file.
right, right. So let me
So I don't want layers to be formed. Instead, layers I want it to be executed as a command. How can I execute that?
so good question. So there are two types of I mean one is the part is Docker file is divided in two parts, the build time part and the runtime part. Okay, in the runtime part, first let's clear the runtime part. In runtime part you can either use cmd or entry point, that is a different case. So but you can use only one runtime process at a time, because a container is again considered as a process, and a process is a process. So a process cannot be multiple process. So because Python 3 is a process, so you cannot say that my process is running two process. It is also running Python 3. It is also running Node.js. So that cannot be the case. It can only execute one process at a time. Either it is Python 3 or Node.js or HTTPD or whatever it is. You can also run simple ls or cd commands also. And about these layers part. So if you want to run any Linux command, you have to you have to use run to run that particular command in a build time. And if you are running anything in a build time, it can be a Linux command, it can be you are copying something, it can be you are setting a work directory or anything. It forms a layer. Each line is a layer until it is a runtime part. This is runtime part. Every build time part is a layer. You cannot escape layer, because layers give you the beauty of optimization. Without layers, you cannot optimize the Docker file. So it is must layer will be created. There is no way to escape layer, and layers are useful. I hope you got my point.
Okay, sir.
Uh, Anybody else? I'll also share this PPT. I have added some basic commands in it.
ஷாலினி ஒரு ரெண்டு
So
நிமிஷத்துல
what we learned today is, these are just a recap.
அவன் கன்ஃபியூஷன் சொல்லிட்டு
What is
போயிருப்போம்.
containerization? Downloading image from a registry, running container in detached mode. We have report mapping. I also had plan of volume mounting. But cannot cover today. I'll share a command with you guys. Docker file and optimization and building our own images. So all points we have covered. I hope you guys have enjoyed.
சார்
Just give me a second.
சார் சார் am I audible?
Hello.
Yes, sir.
Hi, yes, you are audible.
Sir, thank you for this wonderful session, sir. It was so inspiring.
Yeah, thank you, Shalini. Thank you so much. It feels good when a student likes the session.
So I guess that's it, Adil. I'd like to thank you once again for joining on this sessions, and on behalf of the AWS Club at SGIT, I'd like to thank you for joining us and conducting this session on. Thank you.
Yes. Thank you, Jensen. Thank you so much. Thank you, everyone. Hope you guys will do very good in your career journey so you can